A word about continuity. So basically, if a curve doesn't have any gaps, is what we say. So no vertical asymptotes, no point discontinuities, no gaps, then it's continuous. You could start at one end and just travel a path and go to the other end without a break. Some discontinuous ones then. Our hyperbola, I guess, is the classic example there. We've got a vertical asymptote. You couldn't start at the left-hand side and get all the way to the right because there's a break in the middle there. This interesting little graph, x divided by x, which we would think, oh yeah, it's just y equals 1, except we couldn't substitute 0 into that. You'd end up with 0 and 0, and so you get a break in that graph as well. And these sort of functions where they're split into two different functions for different values of x, again, that's not continuous because there's a jump from one branch to the other. So they're all examples of discontinuous graphs. Now why is that important? Because that brings up this idea of differentiability. In order to be able to differentiate a curve, for a curve to be differentiable, it has to be what we call smooth continuous. And not just continuous, smooth continuous. So in other words, there's no sharp points or things like that. It just travels nice and smooth. Something like our absolute value curve, for instance. I mean, it is a continuous graph, but it's not smooth at that point here at 1. Why does that cause a problem when we're differentiating? So remember what the derivative is measuring. It's measuring the slope of the tangent at that point. When you get 1 here, well, is the slope -1? Is the slope +1? Or is it 0? Not quite sure. Because it's not smooth continuous, we can't tell. So that one is not differentiable at x equals 1. A parabola on its side also causes problems because you get an infinite slope at vertical tangent. So it's like saying the derivative doesn't exist. It's an infinite slope. So it's not differentiable at that point. These sort of graphs, what we call cusps, again, it comes down to a sharp point. So we say, no, that one's not differentiable as well. And that's all. So 9K and 9L.